Welcome to RR Max Reduction Formula episode 6. We'll now continue with the problems. Evaluate integral sine to the power of 4x cos cube x dx. I will call it as I4, 3. Again, I'm going to reduce it using the lower power, which is odd power here, 3. So I m comma n, that is for cos term. So you will use the formula which is reducing the cos term. So I m comma n is equal to 1 by m plus n cos to the power of n minus 1x sine to the power of m plus 1x plus n minus 1 by m plus n I m comma n minus 2. Now here it is I 4 comma 3. So m is 4, n is 3. You substitute, you get 1 by 7 cos square x sine to the power of 5x plus 2 by 7 I 4 comma 1. I 4 comma 1 is integral of sine power 4x cos x dx. If you put sin x as t, cos x dx becomes dt. So this will reduce to integral t to the power of 4. On integration, it is t power 5 divided by 5 and you substitute back t as sine. So this gives an answer as sine to the power of 5x divided by 5. So you go back and substitute I4 comma 3 is equal to, again I'm going to convert all my answers in terms of sine. So 1 by 7 into cos square is written as 1 minus sine square into sine to the power of 5x plus 2 by 7 into sine power 5x by 5. So as usual, you take out sine power 5x as common, 1 by 7. So balance is 1 plus 2 by 5 and you take an LCM here, that is 5 plus 2 by 5, that is 7 by 5. So 7 and 7 cancels, which reduces to 1 by 5 sine power 5x minus this term, that is 1 by 7 sine to the power of 7x. So it reduces to 1 by 5 sine power 5x minus 1 by 7 sine power 7x. We'll go to the next problem. Next problem was evaluate integral minus pi by 2 to plus pi by 2 sine square theta cos power 7 theta d theta. Now here 2 is the odd smaller value. So we will actually reduce this, and before that I have my limits from minus pi by 2 to plus pi by 2. Sine square theta will be an even function. Cos theta is already an even function, so the product is also going to be an even function. So this can be written as 2 times integral 0 to pi by 2. So now the given integral will be, I will call it as I2 comma 7, which is equal to 2 times integral 0 to pi by 2 sine square theta cos power 7 theta d theta. Reducing by the lower power. That means for sine I should reduce now. So I use the other formula. I m comma n is equal to 1 by m plus n into minus sine of m minus sine power m minus 1 into x cos to the power of n plus 1 into x plus m minus 1 by m plus n I m minus 2 comma n, where the sine term will get reduced. So you substitute m is 2, n is 7. So that is 2 times that 2 is the outside 2. I've used a curly brackets using this formula 1 by 9 minus sine theta into cos to the power of 8 theta, limits varying from 0 to pi by 2 plus 1 by 9 I 0 comma 7. So I 0 comma 7 is equal to integral 0 to pi by 2 cos to the power of 7 theta d theta. Here you use your reduction formula directly, which is n minus 1 by n into n minus 3 by n minus 5, n minus 2, etc. So 7 is the number n. So here it is 6 by 7 into 4 by 5 into 2 by 3. Now here when you substitute upper limit, cos 90 is 0, so it becomes 0. Lower limit sin 0 is 0, so that is 0. So the contribution of that term is 0. So you have 2 times 1 by 9 into, the answer here is 6 by 7 into 4 by 5 into 2 by 3. Simplify this to give you an answer as 32 by 315. Now you can do this in another way. If you don't remember this formula, you can directly simplify since it's only sine square theta. This is an alternative method. You don't have to do both the methods. You can do one of them. So you just have 2 times integral 0 to pi by 2. Sine square theta is written as 1 minus cos square theta into cos power 7 theta d theta. Now this becomes 2 integral 2 times Integral 0 to pi by 2 cos to the power of 7 theta minus integral 0 to pi by 2 cos to the power of 9 theta d theta here. So for both these separately you apply your reduction formula where n is 7 here and n is 9 in the other integral. So 2 times for the first integral it is 6 by 7 into 4 by 5 into 2 by 3 minus for the second integral it is going to be 8 by 9 into 6 by 7 into 4 by 5 into 2 by 3. You just simplify this. You can take out 6 by 2 times 6 by 7 into 4 by 5 into 2 by 3 as common. And this is 1 minus 8 by 9. Simplify this to give you 1 by 9. So that gives you the same answer 32 by 315. That is your answer. Now last problem, last model here. Evaluate integral 0 to pi by 2 sine square theta into sine cube theta plus cos cube theta d theta. So here again I am going to use it as two integrals and I'll replace sine square as cos square when I want it. So the first integral is going to be integral 0 to pi by 2 sine square into sine cube, which is sine to the power of 5 theta d theta. Second integral was sine square theta into cos cube theta. So sine square I have replaced as 1 minus cos squared theta into cos cube theta. So the first one integral is at 0 to pi by 2 sine to the power of 5 theta d theta plus here 1 into cos cube gives you integral 0 to pi by 2 cos cube theta d theta minus next one is integral 0 to pi by 2 cos power 5 theta d theta. Here what happens is this sine to the power of 5 theta and cos power 5 theta directly you can cancel it and only this will remain, that is integral 0 to pi by 2 cos to the power of 3 theta d theta. For that your formula gives you 2 by 3. Since integral 0 to pi by 2 sine to the power of n theta d theta is equal to integral 0 to pi by 2 cos to the power of n theta d theta. So that we cancel these two directly, you don't have to evaluate it. And for cos cube alone, you apply a formula n minus 1 by n, which gives you 2 by 3. That is your answer. Thank you. Meet you in the next episode.